Now we're going to go through a couple examples. We have a 50-kilogram boy is on his 1 kilogram skateboard. So we're going to say the mass of our first object would be 60 kilograms. He's moving at 10 meters per second to the left. So the initial velocity of our first object, he's moving to the left, so it's negative, right? 10 meters per second. He runs into another 50-kilogram boy on a 1 kilogram skateboard. So our second object that is going to interact is also 60 kilograms. It says that he is sitting still, so the initial velocity for him is 0 meters per second. What is the velocity of the two boys if they stay together? So you have the momentum of the first kid, right? Because he's moving, he has momentum. You have the momentum of the second kid, which essentially he's not moving at all. And afterwards, if they are staying together, well, what do they have in common? They have their velocity in common. And so both masses are moving at the same velocity. So this is an example of a perfectly inelastic collision. So we know that momentum is mass times velocity. So we have 60 kilograms times negative 10 or negative 600 as the first guy's momentum. The second guy is 60 but sitting still, so he has no momentum. So initially our system has negative 600 kilograms times meters per second of momentum. Afterwards, how much do we need? Well, we still need 600, right? We still need 600 at the end, but we don't want to just know that 600. We want to know what's the velocity. So we don't want that 600. We're going to actually solve for the velocity that both of them are moving. So we have our final velocity, both masses, right, of the kids are 60. So we have 120 velocity final. And so if we're looking for that final velocity of the two kids stuck together, actually you might recognize it from one of those video clips. This is a special case if both masses are identical and they stick together. If one of them started at 0, it's a unique situation where they're actually going to be going half the speed. So 600 divided by 120 is going to give you negative 5 meters per second. So both kids are now going negative 5 meters per second, but they still have a total momentum of negative 600 if you calculate it out, right? 120 times negative 5 is negative 600 for their momentum. Looking at our next example, we have a 60-kilogram boy in skateboard. So we've got 60 kilograms, is standing in front of a 50-kilogram girl in skateboard. So our mass 2 is 50 kilograms, right? And they're standing. So the initial velocity of 1 is 0, and the initial velocity of 2 of 0. So because both people are sitting there standing together, not moving, this already I can, right, and they're going to push off, I know this is an explosion. We have both of our masses have the same initial velocity. So we're going to set that equal to, and if they push off each other, right, they're going to separate. So the momentum of 1 and the momentum of object 2 have to equal the initial momentum of our system. Well, they started off going 0. So the initial momentum of the system is 0. So it's kind of like forces in this case. The momentum of the first object has to cancel out or be the negative of the momentum of the second object. Well, it says that when they push off, right, that the boy is moving 5 meters per second south. So our final velocity for that first kid is 5 meters per second, but because it's south, I'm going to say it's negative. Now, you got to pay attention to those directions. So we have our 60-kilogram kid going negative 5, and then what velocity is our girl going? Now, if they were the same exact mass, if both kids were 60 kilograms, hopefully you can see that they'd be going the exact same velocity as each other. If the 60 kilogram boy was going -5, then another 60 gram person would have to go +5, so they would equal 0. But we've got our 60 times -5, right, which would be -300. And when I move it over to the other side, I've got 300. And we've got our 50 kilogram girl. Well, in order for her to have the same momentum but the opposite direction as the boy, she would have to be moving at what, 6? Is that right? Well, let me get a calculator. 300 divided by 50. Yeah, that was right. She would have to be moving at 6 meters per second in the opposite direction of the boy. We're going to go to our next one. Right, a 60 kilogram boy is moving 10 meters per second south. So mass 1 is 60, velocity 1 initial is -10 because he's moving south. He's on a 10 kilogram bumper boat. So that changes this, right? Instead of 60, because he's on a boat, him and the boat are going 70. Another 70 kilogram boy is moving on an 8 kilogram boat. So the mass of our second object in our scenario is 78 kilograms. He's moving at 5 meters per second north. So velocity to initial is +5 meters per second. So we have two objects, each have their own momentum. Right, we have two boys on their boats. They're both moving at different velocities in different directions, so they each have their own momentum. It says, what is the velocity of the 60 kilogram boy? So that was our mass 1. Right, so we want, velocity 1 final. We're looking for that. What is the velocity of the 60 kilogram boy if the 70 kilogram boy, so our velocity 2 final, is moving at 1 meter per second north, which means he's moving in a positive direction. So hopefully, if you think about this scenario, the boy, the 70 kilogram boy in 8 kilogram bumper boat was moving north, and he's continuing to move north, which means hopefully this velocity will come out to be negative, because otherwise somehow magically these bumper boats went through each other. Now they're bumper boats, they collided and they hit, but they didn't stick together, so it's not perfectly inelastic, and we don't know if it's elastic or inelastic. We would have to figure out the energy of the situation, but they do say separate from each other, so we would have that scenario, right? So we've got our first momentum of our kid initially is -700. We have the momentum of our second kid, 78 times 5, right? So he's going to be a positive 390. Afterwards, we're looking for our 70 kilogram kid's velocity if the 78 kilogram, I guess I don't have to write in the kilograms, if the 78 kilogram boy and boat, right, are moving north at 1. Right, oops, wrote that different. 70 V1 final. So initially, one kid had -700, the other kid had 390. So that means that initially there was -310 kilograms times meters per second of momentum. Afterwards, we know that one kid had 78, and so what was the other boy going to have? Well, we move the 75 over, right? We get -385 and we end up with that the final velocity of that kid is 385 divided by 70. It ends up as negative 5.5, and negative would be in the south direction, right? So he went in, he hit, and he was going, right, initially going south, and this guy was initially going north, and afterwards this guy is going north, and this guy is still going south. So I've just created a problem that's really impossible, right? It could be something where you could have to say the error of the situation. There's no way that those two guys just traveled through each other. So it would be impossible for it to happen, but that mathematically would be the answer. The last one, this one's real quick. We're not going to do any work. A 0.5 kilogram dart is fired so that it's moving at 10. So 0.5 kilograms is moving this way at 10 meters per second. Another one is fired towards it, and it's also 0.5 kilograms moving at negative 10. Hopefully you can see that their mass velocities of these two would be identical but in opposite directions. So the total momentum of that system would be 0, which means if they collide and they stick together, what would have to happen is, like you saw in one of the video clips, their ending velocity would be 0. They would stick together, they'd collide, and they would stop. And for the second part, if they were to bounce apart, well, if this MV and this MV, this is another special case that because they have the same mass and the same velocities, what they do is they end up switching, that this object would now have the negative of its velocity, and this object would have the positive of its velocity, right? And essentially they switch. So this object came in going 10, it would leave going negative 10, and this object would leave going positive 10. And that's only because they are the same mass and moving at the same velocities. If they were moving at different velocities, they would literally just switch velocities. Let's say this one was coming in and it was going negative 8. Well, this one would leave going negative 8, and this one would leave going positive 10. They would just flip each other, assuming that it was assuming that it was an elastic collision, not an inelastic collision. Okay, that's it. We are going to do the other problems together in class that were on the notes, and then we will start working on the homework from there.